Hi guys, welcome to Techogenius Academy. We are industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello everyone, I am Akshara Shrivastava from Techogenius Academy. Let's continue the session of NLP basic concepts. Now let me go to the next part of it, which is your NGram. So the NGram is basically the way to identify which set of word comes together frequently. Okay, it helps in identifying the context as well. So if you see here, these are like a co-occurring words. So suppose my text is John is playing football. So there are, since it is like n-gram, so n means the numbers like unigram, bigram, trigram. Mostly we go till trigram. So unigram means you have to consider one word at a time. So if you see here, this entire text got converted into unigram, something like John is playing in football. And bigram is like a combination of two word co-occurrence, right? To how two word occurs. Then it is taking it as a window. Two words as a window. John is, then is playing, and playing football. Yeah. And now same as trigram, taking three words together. John is playing football. Yeah. So like this, you can get the n-gram. It would be basically helpful in understanding the context, and it helps in order to uh, uh, do the autofills and speech recognitions and the spelling corrections also, because it would understand the previous word and the next word in order to understand, okay, this can be the corrected word. So this is where n-grams comes into picture. And this is a formula, number of n-gram that gets generated from a sentence. So here if you can see, we have total number of words as 1 2 3 4, and n-gram, suppose I want 2, right? So from here if I do 4 minus 2 minus 1, it should be 3. So for bigram it would be 3 uh, chunks that it has created. Yeah. So this is where this n-grams comes into picture. Then we have bag of words. So now what is, from here onwards we are looking into the feature generation, how you can convert your text into uh, um, uh, like numeric features which can be used into your ML models. Okay, so if you can see here, the bag of words is nothing but getting the frequency of each tokens for each observation. As you can see, we have 4 observations here. Okay, so we will take the unique words occurring across this. So just consider these as a different documents, and then get the unique words out of it. So if you see here, I've created a unique words, right? And then the entire sentence is going to be represented into the um, numeric values instead of their text ones. So what happens is, against these this vocabulary, it is going to map the word which is coming into our document. So if you see here, John is coming into our dictionary at position 1, so that is why it is 1. Okay, same thing is coming as second position, that's 1. Playing, 1. Football, 1. Then Lee has been guitar, it is not coming in this document, that is why everything else is 0. Same thing you can look into the second sentences, that is wherein the wherever the word is in document as in vocabulary, that index got filled with 1, otherwise if it is not present it should be 0. So this is a way of representing your the text into the numeric form, considering the vocabulary what you are using, and which can be used for your ML models. Yeah. Next thing is count vectorizer. So count vectorizer is a method for converting your text data into the vectors model and can process only numeric data. So in count vectorizer, we basically count the number of times a word appears in the document. So if you see here, let me show you an example how it can be doable over here. So from Python scikit-learn package, we have a feature extraction. In that we do have a count vectorizer just initiated. As of now, let me keep this. Okay, so again this is an English word, and count vectorizer. Okay, what is it does is going to count the number of times that word occurs, right? So you can you know select your um, number of words that you can want to consider at a time. So here NGram, you have to specify whether you wanted it a unigram and bigram or unigram, bigram, trigram. Based on that you can change your parameters. So as of now, let's see unigram and bigram only. uh, yeah, so this will give you like what are the default values that it has taken it up. Okay, so other values are like none, so like max how many number of features that you wanted to include. So you can uncomment these word, and you can see how your this vectors got created. So first of all, let me just go with this ngram as a unigram and a bigram thing. And suppose these are my document. This is the first document, this is the second one, and this is the third one. So it is going to, let me execute it, and let me show you what it is. So here if you see at the rows, right, 0 1 2, so 0 1 2 means your document. This is a zero document, this is the first document, and this is the second one, index, starting index from 0. And these columns, again these columns are your features. Okay, so these columns are your got created based on whatever you have given ngrams, right? So it is taking like enjoying NLP, great, high learning NLP. So all combinations has taken it up, and it just does the count because it's a count vectorizer, right? So it is just counting it up how many times this enjoying is coming in the second document. So enjoying is coming at the first, okay, one time, but enjoying is not coming over here, so that is why 0 and 0. Enjoying NLP is coming over here. High, okay, only high word is coming in the first sentence, correct? So this is a way that you can create your features using the count vectorizer. And here also you can define up to what level you wanted your features. Otherwise, if you won't fix any maximum number of features, like ignore the terms that appear more than 50% of the words, otherwise your a feature, this matrix becomes so sparse if you have a big text data. So you can limit your feature generation using this parameters, right? Using these two basically. So it's like at least 2 times document should occur in order to come up into your feature thing. So in this way you can tune and play around with your parameters. Yeah, and see, I have also executed these things, so you can just have a look into that. And now I have created it for my review data that we are basically working on it. So you can execute on that one, and let me create it into a proper data frame so you can easily analyze that also. So in current text, we do have these kind of words, so you can process it and remove it if you think it is not useful, and see how this got created, this uh, matrix. Yeah, and then as we are only counting words, so it results in biasing, right, in favor of most frequent words. So using this count vectorizer, so we end up in ignoring a rare word which could have helped actually in processing our data more efficiently. So in order to overcome this, there is another method for creating the features out of text, that is your TFIDF, that is term frequency inverse document frequency. So this TF-IDF calculate the relevance of text within the document as well as across the document. Okay, so here you can see there are two things. One is the term frequency and one is inverse thing. So this calculate, see, it's a statistical measure. It is used to calculate how important a word it is there in your document. Within a document, how many times your word occur, and across the different documents, how that word is appearing, how many times it is appearing. So the combination of this will give you TF-IDF. So this is the formula for it. It is just combining this TF and the IDF. So here you can see it is a number of occurrence of the word ith and jl, and number of documents containing that I, and total number of documents. Yeah. So what is the advantage basically over the count vectorizer? So in TF-IDF, we consider overall document weightage of a word, correct? We have considered this as well, how a word is appearing across the word. So it helps in dealing with most frequent word. So using it can be penalized them basically. And this TF-IDF weights the word count by a measure of like how often they appear in the document. So that is wherein this is much more useful as compared to count vectorizer in order to understand how well the word is distinguishing between the two documents. So again, the two common usage of TF-IDF is your information retrieval and keyword extraction. So in information retrieval, in search engine, suppose you type certain queries. So we calculate the TF-IDF for that particular query against your document in order to understand how relevant that particular document is with your query. And the same thing if you have the document, a big document, and using this TF-IDF, you would be able to get the most important word that is there in the document using the scores in order to summarize it to get an idea of what this document is mostly talking about. Yeah. So the here I have given you the difference between the TF and IDF and the count vectorizer that I just spoke about. So this is how you can, implement your TF-IDF using the same package, same as count vectorizer. Same way you initialize it and just fit it on your text. You just see here how it is. So here also it is just creating your here also you can pass your ngrams, right? 1 gram, a unigram, bigram, or trigram. If you are not passing anything, it is by default unigram. So that is wherein it create. You see, this is the get features, right? So I'm trying to get the feature out of it, and these are the features. These are features, nothing but the same as whatever the column that you saw here, right? So these are the different features that it came out. And if I want to print it out or it in a better data frame way, so these are the different features, these are your text, and these are your relevance, TF-IDF score basically. So how it is appearing into your document. So this is much more relevant as compared to account vectorizer. Okay, next move to the next topic, which is the POS. Which POS is a part of speech tagging. Okay, so in our whenever we were when we were in school, so we understood, right? There are 8 part of speech. But the same thing we are going to use here for our NLP pre-processing things. But we will get to know there are a little more number of part of speech available. So I have given you a link. Okay, so here you can see not only 8, but that 8 got again divided into these many tags. So these are the part of speech that we are going to deal with. We want to understand uh, based on what part of speech our text got created. So uh, again, for part of speech, we wanted our data firstly to be tokenized, and part of speech tagging and the next topic that I'm going to discuss, NER, both we can implement using NLTK and Spacey. Let's see with this NLTK one. So in NLTK again, first tokenize the word, so, and then once you get the tokenized data, then apply this part of a speech tag. Let's see how it comes. If you see here, these are the different tokens, right? And these are the different part of speech, and then noun, determinant, okay. So conjunctions and all those things are there, so you can get to understand the full names of this from your this part of a speech list that I have already listed it out. And then is now noun singular mass, right? And then is noun plural. So in that way, your text, your word is going to be assigned with certain part of speech. So why this is important, why part of speech is an important part, again, it is going to be used into your um, autofill, your search, so that it would be able to understand the grammatical structure of your sentence. So whenever you are going to suggest the sentence based on whatever you are writing, so based on the structure of your uh, sentence, it is going to predict the next set of sentences. So that is wherein our part of speech plays an important role. And here this is a brown corpus the NLTK has. I think it has been created in a Brown university, and took it created the corpus from I think 500 different data sources. So let's see, there it is having this tagged words. Okay, so how it looks like, this corpus, how this corpus looks like, let's see. uh, so yeah, so see, this is the size of that corpus, the brown corpus, and this is the first 10 words that I have taken it out, and this is the way the part of a speech got assigned. And when you apply this tag set universal, so these are got normalized into the universal words like a noun, adjective, verb, and determinant, like that. Yeah. Next and last topic I think is our NER. It is a named entity recognition. So it is able, the idea of NER is to identify the entity within your text. So that entity can be your organization, whether it's a person, it's a location, it's a date or a time, or geopolitical entity. What are so I have listed it out also here. So these are the tag it is going to assign to our text. So again, it is going to be there into our NLTK and Spacey. And kind of it is basically is an initial step in order to extract any information from the text. Like this text is talking about which entity. So this is wherein NER plays a major role. So I can show you how it works. So again, this is going to be sentence. It will work on the tokenize and then part of a speech and NER. So I'll show you in a single line how all the things will come up. So see, first of all, the text got tokenized, then it got then part of a speech got attached to that one. And here you can see these are the entities that has been attached to your each tokens. So Joy is a person, Alex is a person. Okay, we don't have anything for the verb working, that's a verb. So let it be. Then Apple as an organization, so it is able to automatically identify that Apple as an organization. Okay, and these are the person. So this is wherein you will get to know the entity of your tokens. So again, an example here, I am talking about Apple. It is able to identify Apple as your organization, but what I'm saying here, Joe is eating an apple, right? So here now Apple is not got assigned as an organization because it is able to understand the context here. Now I have shown you this thing, this NER using NLTK. I'll show you quickly on the same the other libraries, Spacey, just for the different representation. So how it looks like. So first of all, we load that model, pass the text, then NLP. Basically, you have to pass your text into that model so that it would be able to do your different process, which is your parsing, tagging, and NER, tokenizing basically. Okay, and then parsing into your this part of speech tags, and then NER, applying named entity. So just this is my doc, and just iterate to our entities. It is printing your text. These are your entity text, and this is your label that has been assigned. So the other way of representing this NER is this one. So this is a kind of a highlighting what entity it is. So Joey, it is a person, is eating an apple. It's an organization. Then the other thing that I quickly want to cover is in the same model, we do have a depth, which is kind of a dependency parsing, how our word is dependent on the previous word. So you can see here, okay. So same example, Joey is eating an apple. So how this eating is related to an apple, it is saying that it is an object, correct? It is an object. And how this eating is related to enjoy, it is saying that it is a subject, right? And same here. Now how and apple is related to this is an determinant with, and how this eating is related to this verb, which is auxiliary verb, it is. So this dependency parsing also helps in order to understand the context, how our sentence should be grammatically correct. Yeah. So now let's run this thing on our this corpus, whatever we were working on, our review data, and let's see how it gives the data. This is kind of a list-wise representation. Let's look into the this the other way of it. So this is again the same first review of our patient data, and see, it is able to identify like his fourth week is a date. Somehow it is not able to understand that it's not a person. So, and this last week is a date, nearly 8 times its time, Monday date, like this. So the idea is how it is able to create detect these entities. It is because they already have that pre-trained corpus on which is public on public available data, and the corpuses that I showed you in this in this one, right? So those model has been trained on these data, so that is wherein it is able to automatically identify. But what if we are working on some of the data which is very specific to uh, any particular domain, right? So then this won't work. Like in this case, this is not able to recognize whether it's a person or what it is, right? So in that way you can also train your own model. So that is the another kind of session that we are going to look into, that how you can train your own NER, own POS, and run it on your specific area of your data, which is very much specific to your area. How we can do that, but that will come into the subsequent chapters. So hope I think this is NER is the last one that I wanted to cover in the basics concept. Hope you are uh, able to understand, because these concepts are the very initial steps in order to get a good grasp of NLP on the further upcoming steps that needs to be executed to make the data ready for our ML or deep learning models. So yeah, thank you, and we will cover other details in our subsequent tutorials. So till then, happy learning, and please do like, share, and subscribe to the video.